We're going to add two more triangle congruencies to our list, and they are side angle angle and what we call HL. So we're going to start with side angle angle, or sometimes I call it angle angle side, either way. And what it states is two pairs of angles and a side that's not included is enough to show that triangles are congruent. So we can look at this. If we start with two distinct triangles, and here we have our congruence markings. Well, if these angles are congruent, what has to be true about A and D? And if you think of it, A and D have to be congruent. Angle A has to be congruent with angle D, because if the other two are equal to each other and the angles of a triangle add up to 180, then the last pair has to match as well. So the angles of a triangle add to 180. So if you have two pairs already, the last pair have to be congruent. And that's why angle or side angle angle is really just an extension of angle side angle, because I know now that the other sides have to be congruent. And that just gives me angle side angle. So as long as I have two congruent angles and a congruent side, you can prove the triangle's congruent. Now we have to be careful because there are two situations that do not work. If we look at angle, 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 if all three pairs of angles are congruent, that is not sufficient to say the triangles are congruent, because I can have a triangle with congruent angle measures, but different side measures. And I can just kind of show this here, but to prove it, think about an equilateral triangle. An equilateral triangle always has a measure of 60 degrees. So if we had an angle, angle, angle criteria, that would have to mean that every equilateral triangle is the same size. And we know that's not true. So we cannot use angle, angle, angle as a congruence criteria. Now later on we can use it as a similarity, for similarity, but not for congruence. So the other situation we have to be careful about is side-side angle. And that's when you have two pairs of sides and a non-included angle that are congruent. That is not sufficient to show that the triangles are congruent, because you can create more than one triangle with that, and I'm going to show you that in class. Let me demonstrate here. If I have an angle, and say this angle's locked, and this side length is locked, and the other side length is locked up here. Well, that's okay, but this side can actually swing to different dimensions. I haven't locked in this angle, so I could create a triangle like that, or I could possibly create a triangle like this, with this locked and this locked. So I can't prove triangles are congruent if I'm given an angle and two sides that are not when the angle is not in between the sides. Now there is a special case of side-side angle that does work, and this is only when we are dealing with right triangles, because a right triangle, you can only create one triangle when you have a right angle and two congruent sides, because if this angle were to swing around, you're going to get the exact same triangle. So here is our theorem, our hypotenuse leg triangle congruence criteria. When two right triangles have congruent hypotenuses and a pair of congruent legs, then the triangles are going to be congruent. Because, and here's another way to think of it, if we know two sides of a right triangle, well, we can use the Pythagorean theorem to get the third side. So really, this is just an extension of side, side, side. because in theory I could use Pythagorean theorem and get the third side. So here's the deal though. In order to use hypotenuse leg, you have to state that you have right triangles in your proof. So I'm going to show you that in some examples coming up. Okay, I'm going to show you hypotenuse leg in this proof. We are given that AD is perpendicular to BD, and BD is perpendicular to BC, and AB is congruent to CD. So I'm going to mark up this diagram a little bit and say there's a right angle, and these two are congruent. I want to prove the two triangles are congruent, and I've got my given written down. Well, let's get another side because I see that BD is going to be reflexive. So let's take care of that. BD is congruent to BD. That's reflexive. Okay, so I have that. Well, if I can get to a point where I can say that the two triangles are right triangles, that's enough for hypotenuse leg. Because I say they're right triangles, I have a hypotenuse congruent and a leg. So here's how we do that. We start with perpendicular lines, and we say those right angles, are right angles. So angle ADB and angle CBD are right angles. That's because perpendicular lines form right angles. Now I can go back and say that triangle ABD this time, doesn't matter, and triangle CDB are right triangles. Each contain a right angle. That's your reason. Each contain a right angle. If you skip anything, you're going to forget about that step right there. Because you're so used to saying perpendicular lines form right angles and right angles are congruent. I don't care if they're congruent. If you just get them congruent, you have side angle, and that doesn't work. You have to use HL, which means you have to say that they are right triangles. Once you have that, that's enough. And you can now say that triangle ABD is congruent to triangle CDB. And that's because hypotenuse leg is congruent to hypotenuse leg. And there's that proof. If I want to identify the rigid motion to map one over the other, well, there's a lot of things you could do. I think I would probably translate along BD. And then I could rotate about point, what is that going to be? About point D, looks like 180 degrees, and that would map one to the other. But there's more than one way you could do that. You might be able to do a reflection and another reflection, if I think about it. You might be able to do that as well. All right, we're going to do one more proof here. I have BC is perpendicular to CD, so I'm going to draw on that angle there. AB is perpendicular to AD, and I have angle 1 is congruent to angle 2, so I will try to do this. I'm also going to label angle 3 and angle 4 because I'm going to have to use those inside angles instead of the outside angles. I want to prove the two triangles are congruent. Well, in this case I cannot use hypotenuse leg because I have no information about these legs. I can get the hypotenuse but not the legs. So it looks like I'm going to have to figure out how to use angle, side. To get started, we're going to use our reflexive and get BD is congruent to BD. That's reflexive. Okay. Then what I can do is I can say that 3 and 1 are supplementary. Angle 3 and angle 1. And at the same time, I'm going to say angle 4 and angle 2 are supplementary, because they are linear pairs. So, linear pairs are supplementary. Okay. Well, since they are supplementary and since 1 or 2 are congruent, I can now say angle 3 is congruent to angle 4 because supplements of congruent angles are congruent. Supplements of congruent angles are congruent. All right. Now I can say that I also have to say angle, what do I want to say? Let's do it in one step. Angle C is congruent to angle A because perpendicular lines form right angles and right angles are congruent. That's enough for me to say that the triangles are congruent because I have side angle or angle angle side here. So I can say that triangle BCD is congruent to triangle BAD, and that's because angle angle side is congruent to angle angle side. And then if you look at that, all it takes is a line reflection over BD to map one to the other to show that that triangle is congruent. So we will practice more of these in class. Now you have 5 congruence criteria to use for your triangle proofs.